Hello friends, welcome back to my YouTube channel Quality Talks. In the previous video, we learned how to perform multiple regression analysis using Microsoft Excel. In our example, our objective was to predict the flow rate based on three process parameters: injection pressure, nozzle diameter, and fuel temperature. We entered the data, selected the input and output ranges, understood all the options in the regression dialog box, and finally generated the regression output. But simply gathering the output is not enough. The real value lies in understanding what this output tells us. In today's video, we will interpret every section of the regression output step by step and understand how it helps us make engineering decisions. So let's get started. First regression output is this regression statistics table. In regression statistics, we have first parameter as multiple R. Multiple R is correlation coefficient between actual flow rate values and the flow rate predicted by our regression model. In our case, it is 0.9047. So in our case, the correlation is very high. It shows a strong positive correlation. R square is coefficient of determination. Coefficient of determination explains the variation in output variable due to the input variable. As in our case, the value of R square is 0.8185. That means 81.85% of the variation in flow rate is explained by these three input variables. Those are injection pressure, nozzle diameter, and fuel temperature. The remaining 18.15% variation is due to other factors that are not included in this regression model, such as measurement error, machine variation, environmental conditions, and other variations. However, there is one limitation of R square. If we add any new variable to the regression model, the R square value either increases or remains the same, even if the variable is not useful. That is where adjusted R square comes in. Adjusted R square increases only when the new variable generally improves the regression model. If the new variable does not add any meaningful value, the adjusted R square decreases. We will understand this practically by comparing two regression models, one with fuel temperature as a predictor and other without fuel temperature. Now let's understand the next important output, which is standard error. Standard error tells us how far our predicted values are from the actual values. In simple words, it measures the average prediction error made by the regression model. Suppose our regression model predicts a flow rate of 100 liter per minute, but actual measures flow rate is 103 liter per minute. This difference is called the prediction error or residual. Now, standard error summarize these prediction errors into a single number. A smaller standard error means predicted values are very close to the actual value, indicating that our regression model is more accurate. On the other hand, a large standard error means the predicted values are farther from actual values, indicating lower prediction accuracy. One thing need to be remembered that standard error is having same unit of measurement as of the response variable. In our example, standard error is 0.970. Now let's understand what this standard error of 0.970 means in practical terms. Suppose our regression model predicts a flow rate of 100 liters per minute. Since the standard error is 0.970 and assuming the prediction errors follows a normal distribution, we can estimate the range within which the actual flow rate is likely to fall. Approximately 68% of the time, the actual flow rate will lie within one standard error of the predicted value, that is between 100 plus minus 0.970. Approximately 95% of the time, the actual flow rate will lie within two standard error, that is between 100 plus minus 1.94. And approximately 99.7% of the time, the actual flow rate will lie within three standard error, that is between 100 plus minus 2.91. Now let's compare the regression statistics of the two models. The first model is without fuel temperature and the second model is with fuel temperature. First output parameter is multiple R. So in both the cases, multiple R is 0.905. This means correlation between the predicted flow rate and the actual flow rate is exactly the same in both models. So adding fuel temperature has not improved the correlation. Second output R square. So in both the cases, R square is 0.818. This means 81.8% of the variation in flow rate is explained by the regression model, regardless of whether fuel temperature is included or not. Fuel temperature is not increasing the explanatory power of the model. We have seen multiple R and R square. Both are same in both cases. Here comes the role of adjusted R square. Now if we compare the adjusted R square, then without fuel temperature, the adjusted R square is 0.805. While after adding the fuel temperature, it decreases to 0.798. Remember what we discussed earlier, adjusted R square increases only when the new predictor genuinely improves the regression model. Here instead of increasing, it has actually decreased. This clearly indicates that fuel temperature is not adding any meaningful information to the model. Instead, it is only making the model more complex. Let's see standard error. Without fuel temperature, the standard error is 0.952. After including fuel temperature, it increases slightly to 0.970. We know that a lower standard error indicates a more accurate regression model. Since the standard error has increased, it means that the prediction accuracy has actually become slightly worse after adding fuel temperature. So, final conclusion is fuel temperature should not be included as a predictor in the final regression model. So friends, that is all for this video. In this session, we covered the first section of the regression output, regression statistics, and learned how to interpret multiple R, R square, adjusted R square and standard error. In the upcoming videos of this series, we will explain the remaining section of the regression output, including the ANOVA table, regression coefficient, p-values, residual analysis and diagnostic plots. If you found this video helpful, please like, share and subscribe to Quality Talks channel. Also press the bell icon so you don't miss the next video in this regression analysis series. Thank you for watching. See you in the next video. Until then, keep learning and keep improving.